Добрый день, коллеги. Я
Hello.
сегодня расскажу о нашей
I'm going to speak about
помощи машинистам локомотива.
assistance systems to locomotive drivers. My name is Yuri Minkin. I'm head of Department of Driverless Systems at Cognitive Pilots. A couple of words to explain why our system is needed. The system is installed on locomotives. It's maneuver locomotives. It is targeted at forestalling accidents. So the system allows handling the hazard of following the wrong signal of the traffic light, the hazard of trying to pass the switch in the wrong direction, which means that either this train can go off-rail or the next one. The next type of problems that the system can detect is a collision with people, collision with other rolling stock items, and also the hazard of hitting into the end block. In all these situations, if the time allows, the system warns the driver. If the driver doesn't respond, it initiates automatic braking. The system knows braking curves, that the length of the braking path, and in the current condition, considering the load, the angle, and the distance, the system will take the easiest way of braking so as to avoid the collision. There are three types of braking. That's regular, full, and emergency. This slide shows a schematic of the CHV-3 locomotive. It's quite a well-known maneuvering vehicle. The system has now been installed in a number of such vehicles. The red points show the cameras, and the blue ones are the position of radars. So basically, it's a complex responsible for the vision of the system. This slide shows the camera unit. It includes 3 or 4 cameras. The system must work from the lowest range to the farthest, because the brake path of the locomotive is quite long, even if it's rolling alone, and if we're talking about the whole train, it can be huge. We have to operate in quite difficult conditions because there's a lot of vibration, and it poorly reflects on the picture quality. So we have a vibration control system built in. With here, this one shows the damping elements, but the new system will include electronic vibration removal technologies. So the system of cameras, the camera unit has a climate control system so that the system could operate in any conditions. Also, for dust, there's a wiper and washing system. This slide shows the radar. The radar produced by our company. It runs at the frequency of 2.4 gigahertz. I will later show you a video how it works. I want to mention that the railroad scene is very good for radar use because there are a lot of radio wave reflecting elements. There are rails, there are posts. It's all metallic and it reflects the signal, but there are also re-reflection things to be considered. But this radar works quite well and provides high quality of detection. As I've already said earlier, We use 3 different zones to see from closer to longer ranges. And now I'll show you from a single spot what kind of vision we have. This is the close range, up to 30 to 50 meters. So this is the medium range zone, so up to 120, 140 meters. And this is the effective range with this camera. And this one is a long range zone with the effective range from 400 to 600 meters, depending on the conditions. But I must say that because we're talking about maneuvering vehicles, we don't often need to engage that range, because visibility is usually shorter than that. So this slide shows you how the system operates. So it's a recent recording. I'm showing you, let me just stop it and show you. If you look here at the top left corner, it works how the system works under the hood. Under the hood, there are several neural networks. In this particular case, this is the network that splits the whole scene into classes. And so each item here is classified as belonging to a certain class. And also you see rails, you see traffic lights, rolling stock items, and people. And on the right, you have the UI of the system. Most of the screen is taken by video, because the layout of the locomotive is such that the driver has a very large blind zone. And so they usually work with 4 eyes, the driver and assistant, just looking in different directions. And the assistant also informs the main driver whether the traffic lights have changed and the switch has fired. But now Russian railroads are trying to use a single driver. And so even a picture from the camera is a very good assistant to the driver to take a look at what's happening. They can switch between them and see the situation ahead. At the bottom left, we see a red person, which means that the system has detected hazards and triggered braking. Let me switch the video, and we'll see how it runs. So roll back a little. So when approaching the person, the system issues a signal. It sees the object. This strip, red light, shows that there's a hazard of collision, but because the distance is small, the system automatically triggers the braking. On the right, there's a button, and you need to press it once the system has braked to resume motion, because otherwise you won't be able to do that. At bottom left, there's a button of overriding the braking. In certain situations, the driver needs to pass the red light when, for instance, in different situations. And then you just issue this instruction. The dispatcher passes this instruction back to the driver, and then they disable the system using this button. This slide shows the procedure to prepare data for markup. Data is perhaps the most valuable thing that we collect. We've been working with Russian Railroad for quite a long time, collecting all sorts of data, different lighting conditions, and the data is exactly what allows the system to work effectively. This slide shows how the detection network operates. This network is targeted on people and vehicles, because our company doesn't only have projects in Russian Railroad but also in other industries. This network runs quite fast. It's quite lightweight. Here it's auxiliary, but is used as well. This video shows you how traffic lights detection happens. Well, there are more lights in Russian Railroad than on roads. White signal is the allowing signal. Red and blue don't allow motion, so the drivers know different combinations of signals to respond. What's the peculiarity of traffic light detection? The color changes a lot depending on the lighting conditions, day, night, twilight, on the type of signal. And because white includes all spectrum, you can see white and blue when you see red and blue if you see light in certain conditions. So it's a whole art to make a system detect these lights in a stable way, these colors in the same way. For this, we use segmentation-based network that identifies traffic lights in the frame, and then a detection network is engaged to identify the color of the light. This slide shows you the station map. Actually, two aspects of problems. First, to build a map for the system to work. Geodetics professionals go and map the station. It's quite a detailed map with switches, traffic lights, posts. The station itself is quite a complicated site, and if you get there for the first time, you'll perhaps never understand which traffic light is responsible for which path, which track. So we put in the system so it should properly detect it. And basically, if a driver has never worked in the station, they require this path from the dispatcher. We teach the system to do that, of course. And the second part is high-precision positioning, because we need to know for sure which track we're on. On the one hand, the step here is quite large, but on the other hand, if we get confused with the track, we'll get confused with everything. We'll never know which traffic light to follow, which switches are in front of us, and that's very bad for the quality of system operation. So you may think it's just a simple problem, but in fact it's quite difficult to solve, because GPS reception is not perfect. RTK adjustments are not always accessible, and we can get into a station where GPS will take us away by dozens of meters. And we use several approaches to improve the accuracy of positioning. We use also visual methods. If you remember, we detect posts, and one of the reasons why we detect them is also to help us position the device. It's actually quite unique algorithms, but it's one of the things that helps us to identify our position with high accuracy. And finally, there's a radar that detects different objects around the locomotive. So all this information gets on to the input of the particle filter and allows us positioning the locomotive with the accuracy of 20 to 30 centimeters. And the last slide, I'll show you how the radar works in a railroad station. As I said, there are a lot of reflecting objects. You'll now see red dots on the right. It's people. People is an object that's very difficult for a radar, because human body's physical property poorly reflect a radio signal. And it's real art to make the radar see an object like that in a stable way with all this interference. But as you can see, it all works pretty well up until maybe 100 or 130 meters. People can be seen quite well. But of course, our primary sensor here is cameras. So the radar is just an addition. For instance, the radar always provides us with the information about the speed, because identifying speed by video is quite a sophisticated task. To the colleagues, I'm done. Thank you for your attention.